In this video, we will discuss the concept of the RC time constant. In this circuit, we have a RC circuit consisting of a 2K ohm resistor and a 10 microfarad capacitor. Initially, this capacitor is discharged. There's no voltage across it with the switch open. As soon as the switch is closed, then charge carriers begin to move from the source towards the capacitor. And over a period of time, then the capacitor begins to charge. In other words, V sub C starts out at 0 volts, but then charges up to the maximum voltage applied by Vs, which is 10 volts. The rate of charge is determined by what's called the time constant. The time constant is equal to T tau is equal to RC for a resistor capacitor network. That value in this circuit is equal to 2K ohms times 10 microfarads which is equal to 20 milliseconds. So the capacitor charges at this rate, and each tau the capacitor charges so much. In 20 milliseconds, the capacitor charges up to 63.2% of the total voltage. So in 1 tau, we have this equal to 20 milliseconds. And that's equal to, or the charge of, the capacitor charges to, up to 63.2% of the total voltage applied. So that means in 1 tau, then we charge up the capacitor to 63.2%. Now in 2 tau, this is equal to 2 times 20 milliseconds, which is equal to 40 milliseconds. And the capacitor will now have charged to a value of 86.5% of the total applied voltage. So in 2 tau, we charge up to a value of 86.5%. Now in 3 tau, 3 time constants, which in this example is equal to 3 times 20 milliseconds, which is equal to 60 milliseconds. The capacitor will charge to 95% of the total applied voltage of Vs, which is 10 volts. So the capacitor is slowing down its rate of charge, but it is still charging. Now in 4 time constants, which is 4 tau, we have 4 times 20 milliseconds, which is equal to a total of 80 milliseconds. the capacitor will charge up to a value of 98.2% of the total applied voltage. So in 4 tau, the capacitor charges up to this value. Finally, at 5 tau, which is equal to 5 times 20 milliseconds, which is 100 milliseconds, the capacitor will have charged to a value of 99.3% of the total applied voltage. So you can see that a graph of that rate of charge would look something like this. So after 5 time constants, we consider the capacitor fully charged. The time constant depends on the amount of time, and in this example it took a total of 100 milliseconds to reach this 5 time constants, and that will vary on each RC circuit based on the resistor value of R and the capacitor's value C. However, these percentage values, 63.2 at 1 tau, 2 tau 86.5, 95 at 3 tau, 98.2 at 4, and 99.3% of the total applied voltage at 5 tau never changes. Those values, those percentage values, will always remain constant. This could be used to calculate the amount of voltage on a capacitor. For example, here, if we wanted to know what the voltage at 2 tau was, then we could say the voltage across C at let me correct that, make that look a little bit better. At 2 tau is equal to the applied voltage, which would be 10 volts, times 86.5%. Multiplying this out, this comes out to be 8.65 volts at 40 milliseconds. This concludes the video on RC time constants.